All right, we are live. This is Hangops for April 15th, 2016. Running a little late, got some computer issues. Computers, not even once. Um, got some cool folks on today to talk about computers. Do a quick round of intros, and then we'll just kind of muddle our way into the topic. Start on my left. Charity.
Hi, Charity. Working here at Hound with Rick. Ranted a bit about Java last night and got what I deserved from the internet.
John.
Oh, me?
Yeah.
John Willis, Botchkaloop on Twitter. Completely stayed out of that Java thing. I woke up and saw this morning, but in general, I basically agreed with you. I think your point was well taken. But anyway, I'm here to talk about anything else you want to pick my brain about.
Yeah.
Some stuff I've been working on, or
All right. And Rick.
dare talk about Docker new stuff. I could do that too. So.
Cool.
I'm Rick Branson, R. Branson on Twitter. This is my second Hangops. I'm sure Charity's been to like 10 of these or something. But so I work with Charity at Hound, and I'm a professional sunglasses and leather jacket wearer today. So
Nice. All right, cool. So, yeah, today's sort of ensemble was prompted by some tweets Charity made last night. Which what I thought would be interesting though is it was sort of an interesting discussion around what is a good sort of practice level topic, shall we say, which is evaluating how you introduce new technologies into your stack. Right, especially like if you're looking at adding like a new service of some kind that is on some kind of a language runtime or backend that maybe brings its own sort of whole new world of tooling and monitoring and so on. So I guess to kick it off, maybe Charity, you give us a little context around like kind of like where what you want to say about like kind of the environment you were setting things up in, and then what drove bringing the JVM into that, and just sort of, your experience with this kind of stuff in the past, kind of whatever.
100%. So the reason I started tweeting was because I was Googling for probably the 11th time in my life, how do I fucking set up JMX? And it's just like, I've never worked in a real Java shop, but I've repeatedly had this experience where the only viable production-worthy solution for the problem that I need to solve is a Java thing. Zookeeper being the prime example. And now at Hound, we're also using Kafka. And so I need to fucking monitor this piece of shit, right? But I'm not a Java person. I don't spend my day in Java land. So every time, like it's infrequent enough that I have to build a Java thing or fix a Java thing that I have to learn it from scratch every time. So I started ranting about it a little bit, and like a lot of people kind of saw one tweet or two tweets and thought I was just shitting on Java. If I'm shitting on Java, you'll know it. Okay, like I could shit on Java, but that actually wasn't what I was trying to do. I was just saying how painful it is that you have, this whole rich ecosystem of tooling, and it's like an operating system, like doing Java right and running Java right. And for those of us who aren't doing Java all the way, it's really painful. It's really painful to every time you have to set up, all the monitoring and all the tooling, and then like Zookeeper breaks at 2 a.m. and it's not a language no. It's not, I have learned and forgotten how to optimize the JVM like 3 or 4 or 5 times, but I do it so infrequently that I have to learn it all over again every time. So that's kind of what I was ranting about. And there's a lot of legit maturity and good things about Java, which Rick continually reminds me about. But it's very heavyweight, right? Even compared to like your Ruby, your Python, every environment has it. they don't play well with others. But Java is especially heavyweight, and debugging that shit at 2 a.m. without a lot of context is a piece of pain that I have felt over and over, and I expect to feel many more times. But like the fact is, like Zookeeper's still the only fucking thing that works, right? For service registration and discovery. So we use it. Kafka, best message bus out there. So we use it. But we're not choosing to build the rest of our stack in Java because it's incredibly heavyweight, and it doesn't play well with other things that we want to do. Who wants to argue with me?
I agree. I mean, I don't. I mean, I'm reasonably pro Java in general, but I totally agree with you that making choices of products and knowing the underlying framework of it, and if you don't have the skill set for that, it's exactly what you described. I mean, John Vincent tried to create something called Noah years ago because, that was a big part of the reason why he did it. He was trying to create a Ruby-based Zookeeper. It never really went anywhere, but I mean, there were other reasons too that, the constraints that Zookeeper had. But again, I saw your tweet. I mean, I woke up to it, so I didn't. By the time I saw it, it had decayed, where people were talking about like stop mansplaining and stuff like that. But yeah, I know. But the point is, as I went back to the tweets, I was like, I think your point was, you were spot on. Like, that it's either something you have to fully invest in, and and it's a conundrum. I think there's ways to get around Zookeeper, but you're right. Kafka is so even if you found your way around Zookeeper, you'd be right back in it with Kafka anyway. So yeah, it's an interesting.
What I want is for there to be like a minimal set of, okay, so you need to run a Java process. Here is your Java for Dummies. here are some really stupid things that you should know about, if you're running Cassandra or if you're running Kafka. Like, Rick, you can talk about Cassandra. Like, how wrong are every single one of the JVM defaults that it starts up with, right? It's like, I want just like...
Yeah, well, so I think the like one of the interesting things that you said that I think stood out to me is that Java is like an operating system, and I think that that's kind of the whole point of the JVM when it began, right? Because it's like, oh, well, we can code once to run anywhere, which probably better than most things. The problem though is that when you sort of, Java is like so technically really great at, so it's solved like a lot of really, really hard problems. Like, it's got a lot of really solid implementations for things that are generally weak in most ecosystems. That it's just really mature. The problem is that like Java basically solves these hard problems and then never really gets to the like soft problems of making it usable by humans and consumable. Just like literally like from the very beginning that you start interacting with Java in terms of from a end user perspective, like, okay, the first step is to go download the JVM. Well, because of the way that Oracle has structured the download process, you literally have to go and like go to this website and like click a form and click accept, or you're breaking their end user license agreement. And so all these people have built all these like build your own Debian package by like going and downloading the tarball and then like copying it in this directory and running this shell script, and then you're okay to distribute it within your company. And that's just where it starts, right? Like it's repeatedly sort of like habitually line stepping in terms of the human to computer interface, and it's a damn shame because there's a lot of really great software that's built in the JVM and a lot of really great tools and things that sort of get, they sort of are, people don't even see because there's a big nasty JVM in the way. So that's kind of how I see it.
Yeah, and the thing I've run into a lot, especially when I was at Lookout previously. part of my role there was productionizing Zookeeper and Kafka, and then helping with some Cassandra stuff. And I got very familiar with JMX Trans, right, which is its own Java project to sort of it pulls to ingest metrics via JMX, and then can write them to a variety of backends. And in our case, it was for Graphite. And even just stuff like different CLI clients for JMX and things, like it seemed like there was like nuggets of distributed knowledge, but I always kind of wondered, like, okay, there's a lot of big companies running a lot of like stuff based on Java, right? Like there's all the enterprise Java application servers, and you see Cassandra and all these things everywhere. So it's like, is everyone like building like the same shell scripts or Ruby or Python scripts or Java, things in a jar over and over again, and nobody's sharing it? It's like, where was the, there didn't seem to be a similar body of work around kind of like the operational side of things as you find the same way in some of the more interpreted language environments. So it's sort of like, where is all that stuff? Why isn't it as like prevalent?
Yeah, I find Java to be so, and like you all know my background and my biases. I don't come from enterprise. I have never worked in a robust, mature Java shop, which is why Rick and I keep having these entertaining arguments where he's like, these things you're complaining about don't have to be true. You can totally have a functional dev environment with Java, and let me show you, and it will seriously only take us 2 weeks to set it up, but then it's going to be amazing. And I'm just kind of like, okay. I believe it can be done well, but you do have to really invest in it, right? And some of this does speak to the moment in time when Java was created. It was created using the best practices. I'm going to go even farther and say it was a giant improvement on the state of the art in computing languages, and like it was containers before there were containers. It was Go before there was Go. And a lot of people will get all, cranky, fist shaky, and be like, oh, why would you shit on something that works and has been, powering, software for decades? And it's like, okay, yeah, fair. There's worth to that argument. But also, software does get better, and languages do get better, and operability does improve. And so, like at our startup, we have not chosen to use Java. We could solve the same problems with Java as we are now solving with Go. But the deployment process has gotten easier. I think that the tooling has gotten better. The operational aspects have gotten better. And it may not be as mature, but like we're making an explicit choice to trade off very mature, very heavyweight for something that is newer. We're going to need to implement a few newer things for it, but that we believe is worth investing in and is ultimately going to be an improvement. It's just like I was being snarky and an asshole on Twitter to people last night, and I'm like, oh, let's use COBOL because that's stable. That's been powering transit systems for the last 30, 40 years. Like stable is only part of the argument or the reasoning that goes into choosing a technology, right? Like maturity is a thing, and you trade off the maturity for other things like velocity and speed of development and operability.
Well, I think the one thing that we're really we're really talking about here is like, what is the end user experience for using third-party applications that are Java-based, right? And it's not great. Like it's you do have to really like to use them effectively and monitor them and operate them. You have to like sort of adopt a lot of indirection from the Java platform, where that generally like in systems that are managed, that are in sort of lighter weight runtimes like C, they're doing all of this kind of custom stuff under the hood that makes this these types of issues not really, they don't really like come to the surface as much. because they're sort of doing their own thing. Java is the trade-off between developer productivity and compared to, say, like writing something in C, between developer productivity and the sort of end user experience in that respect. So I think the frustration is that it's like often you just want to get something done, and if you're not a JVM shop, it's like to Charity's point, like you're spinning up all of this, like you're going to learn a bunch of stuff about how to administer this stuff, and it feels like you're throwing it away because it's like once you've gotten over that hump, you often are unable to reapply those things effectively just because you
exactly. I would so much rather be able to be an expert in Linux debugging. Like I feel like I can use the same techniques and tools and monitoring and shit to like debug a Go binary as a C binary or as Ruby or Python. Like I'm not expert in any of these things, but I feel like the same tool set is roughly applicable to all of them. I can monitor them the same way. I can and with Java, it's like, no, I'm stepping into a foreign land, and none of my knowledge really applies. I fucking trace a Java program, and I'm like, this is not helpful. And there are magical Java commands out there that would be helpful to me, and I can spend a few hours looking them up and using them, and then I will forget them again because I don't use them every day. I would rather be a Linux debugger than a Java debugger.
So I'm guessing you're not a big fan of unikernels. Not trying to derail it. Sorry, I just don't want to go Brian Cantrell here. So
part I'm wondering is why this sort of divergence in a sense with sort of Java on the server in terms of tools are somewhat opaque. There doesn't seem to be as big of a body of accessible knowledge compared to like other interpreted languages that we commonly use on like web development and server development. And also, I feel like it's always been sort of a running joke that like all the init scripts that come with any of the Apache projects, right, your Tomcats or whatever, are like they're essentially useless. Like what's in them is like not suitable for anything. If sometimes they don't even work. So it's sort of like, there's not even real good guidance on like, how do I run this on the server? It's like, why does that side of things seem to be so like lacking?
Well, I mean, again, I'm not even close to an expert in this whole discussion because I'm not really a Java guy in general. But I think it goes back to if you pick your poison. Like right now, I think the Spring Boot stuff is pretty interesting, right? But that's a kind of buy-in to an architecture. I think to the original point, the spray comes when you've bought into a certain architecture, and then all of a sudden you have to use this product that has this framework that isn't based, doesn't really have a mature. It's an implementation of a Java application, and that's it. And I think that's the point. I think I think not that the world needs me to defend Java by any means, but again, I think looking at Java apps that get dropped in your lap and how you manage them versus buying into something that like what the Spring Boot and I've just played with a little bit, but I think there are some reasonable lighter weight frameworks to get a lot of what you need from not only delivery but manageability. There, I said it.
And I think this comes back to, like, we've said this a couple times, but like just to reinforce it, like when you buy into deploying a Java app, you're not tuning the app or its config settings. Like you are configuring an operating system, essentially, and that's just not something where you can pick sane defaults that are going to work for everyone in as many environments, like just the range of different types of variables for setting different kinds of memory settings and garbage collection settings, and it's just like the defaults that you would pick for like me running Cassandra on EC2 using C3.xls are going to be completely wrong for someone who's using it to run, Zookeeper in a data center, completely different hardware. It's just, and when you're not using Java, generally your operating system is picking those defaults, and it does a better job.
So, getting a little bit more meta, how do we go about assessing the complexity of adding a new piece of technology to the stack? Like, what are the things you look for? Maybe what are the sniff tests? Someone's like, hey, here's this super cool new key value store that I want to use, but it's da 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 da, and we're like, well, we don't, I don't know anything about that. How do you even start like figuring out like what would be the sort of total cost of ownership of adding this?
So like the first thing to look at is like what is your appetite for risk, right? What stage is your company at? What kind of guarantees or loose guarantees have you made to your customers? If you have any customers, are they paying you? Do you have the freedom to kind of like at this point, like I am doing riskier things with technology than I ever have in my life because I've never started at a company this early, right? Like Terraform, great example, right? If I was at Parse, this actually came up. We're 4 years into it. We have a pretty stable infrastructure using auto-scaling groups. No pressing need for something like Terraform. And a couple of the guys wanted to like backpatch it onto our infrastructure, and I was like, hell no. Like, what problem does this solve for us? And it's going to break things, and it's going to be messy, it's going to be awful. Okay, but at Hound, we have invested in Terraform because even though it's young, we believe it's the future. We believe that composable infrastructure and orchestration is the future of infrastructure, and we have a few months to like really get comfortable with it. We don't need best practices necessarily handed to us from the community because we can develop them and share them with the community. So I think like organizational appetite for risk and just being aware of like trading off the risk you can accept, the risk you can hand off to your customers versus the perceived value that you get back from introducing this risk, right? Like the classic example that I've used so many times is like if you're running a team and you're all happy, you're all using Red Hat, and some douchebag comes in and is like, I want to use Ubuntu. No, fuck that guy. Like the delta between Red Hat and Ubuntu is so small that there is almost no justification for like running both or switching from one to the other. If you're running MySQL, though, and you need to do something radically different that MySQL isn't optimized for, using something like Titan, if graphs are your thing, or using something like Redis, if like sophisticated caches are your thing, like those bring enough difference and can make a big enough impact in your lives and your product that it's worth the increased risk.
I think the other important thing to do when you're assessing is understanding like, can you actually fully buy into something? Like when you've made part of the decision making process should be like, are we really willing to go all in on the system? And it's not good enough just to be like, okay, this solves a problem for us, but you also have to like understand the fact that it's like you're not going to be able to just install it and set up a Docker container with it inside and just like go and just like, oh, it's going to work forever. Like, no, this is like just part of your stack now, and you need to like treat it like you would any other really important part of your stack. Otherwise, you're going to have a terrible time. I think that if you any part of your stack, you really should be like committed to becoming an expert in. So maybe one of the outcomes of when you're bringing something on and you're feeling pain is like a lot of it is because, well, I don't feel like I have time to really become an expert on this thing, and that should be a warning signal of like, maybe we should reconsider this decision. So, I think in Charity's situation right now, it's because she's having to adopt like 10 different new pieces of technology simultaneously. So there's a little bit of extra burden on that. But I definitely think the thing I learned at Instagram the most when we adopted new technology was that you had to buy in and you had to like really commit to being an expert in this technology or figure out something else out. It's better even if you have to do something that's maybe a little bit not perfect. It's better to not have those, to not introduce new pieces of your stack. Don't use your database as a queue, but that may be an okay solution if you're not willing to totally buy into something like using RabbitMQ or something like Kafka. So that's kind of, I feel like maybe a second part of that question.
Yeah, and there's a whole question of critical path versus non-critical path, right? Like the shit that's in your critical path, like what Rick is saying, 100%. Like you have to buy into being an expert at that shit. Not everything's in the critical path, right? There is room for people to like anything that involves like an offline ETL process or like that's experimental, that's not going to take your API down. There's more room for let someone take it, try it out, see how it goes, see if it's something that we feel like we can rely on after using it for some experiments. Like I feel like there's place for not being too rigid because organizations should value creativity and new ideas. So like another example from Parse is one of our engineers was like Docker, like really wanted to do Docker something, and it's like, okay, dude, well we're not gonna redeploy the API using Docker, but if you really feel as passionately about it, take Jenkins. Jenkins is broken. Go Dockerize the fuck out of Jenkins and come back to us with your findings. And he came back and he was like, yeah, it's not ready yet. So it's really good because he got to feel like we weren't being just like total assholes, being like, no, your ideas aren't valuable. We got to get some experience in the technology, but it was like our test infrastructure, so it didn't actually hurt any Parse customers.
So, I'm not trying to brag or anything because I'm just going to use it as context. I've probably done about 10 startups in my life. And at the meta level, the thing is you just never really know until you know. I mean, even like that Docker example is a good example, right? I know, and I'm an advisor on about 4 or 5 companies too, right? Again, just trying to set the context is that I saw one company that believed fundamentally everything they should do, what they knew, they were industry experts, really smart people who decided to go with Go. 8 months into it, it was a really bad decision, right? And so again, there are context specific to the startup, the problem you're trying to solve, all the things. And so I think in the end, the real answer is A, it's hard to do these things, and B, you've got to put some minimal viable initiative into what you're going to try to do, but and you make your best judgments. But at the end of the day, almost every startup is really kind of different, and sometimes the problems that you're trying to solve, again, I'll go back to these guys who were as smart as a whip, decided to go. They didn't choose Go because it was a hipster language. They were really smart people, and 8 months, 6 months into it, they pivoted to another language and framework, and their decisions of how they did it were pretty strong and bold, and so I sound like I'm rambling, but my point is that like whether you choose Docker, I mean Docker works for CI and Jenkins, but not in every example, and Java may not work in every example, even Spring Boot may not even work. So the question is, when you're building new architectures and software and frameworks for some things, there's a big risk in your decision process of what you do and the amount of technical debt you have to apply to that learning curve of it. And sometimes you win, sometimes you don't.
100% agree. Like technical decision making is completely contextual, right? Like at Parse, we underwent a almost 2-year long effort to rewrite our API from Ruby on Rails to Go, and it was hard, but it saved our asses. Like seriously, we got an order of magnitude more reliability, and it was hard, and we had to like blaze the trail, but it was totally worth it, and I would do it again. But that doesn't mean that I would tell every startup to use Go, right? Like these are contextual things. It depends on the people that you have. It depends on your use case. It depends on your experience, and it depends on what you're trying to do. And these are not always things that are knowable in advance. So, like, I think that, to your point, reevaluating and taking stock and being able to change your direction when necessary is just as important as choosing the obvious right thing from the start.
So one thing I think is interesting is I think we're conflating two different types of choices here a little bit without even realizing it. One is choosing to introduce something into the environment that we're primarily going to be operating. For example, Kafka, right? You're going to spend far more time having Kafka run and you're using it as a service than you are potentially going to be like actually writing Scala or Java to contribute to it, versus the language runtimes that you're building your custom software, right? The sort of the new software that is for whatever you're building. Because when I think about like do I want to what do I want to develop in, to me that adds a whole different set of requirements like IDE support, community, dependency management, build tools, CI testing, linting, flake testing, like all of that stuff. Okay, so there's an entire chunk of like development requirements that are pretty different from if I just think, okay, I'm gonna start operating something. But then there's a subpoint there in that like it's interesting how much of there's it's a cultural thing in that there's this big divide in terms of like there's a lot of people that operate a lot of things that they wouldn't be capable of hacking on, right? Or potentially even contributing a patch to. They're running things in languages that they simply couldn't potentially contribute like a fix to or figure it out. And that may, for better or for worse, that may also be part of what contributes sometimes to the lack of knowledge, because the reality may be that a lot of the folks that are developing even like big open source, software projects that are essentially like infrastructure projects may not be operating them in production very much, or may not be operating them at large scale, and that's can what lead to things like the operational part of the help or the init script or the whatever is not.
Totally. I mean, like, let's be honest. How many of us here, besides Rick, would be capable of like submitting a patch to any of the databases that we run in production in the middle of the night, right? Like, not me. And yet, I think that the reason I started ranting about Java is because it is in a different class as far as I'm concerned. Like, I have never really had a problem finding problems in databases like Mongo or MySQL. Not like I have had problems finding problems in like Zookeeper. I think that they assume a lot more specialized knowledge in the Java world than they do in like the C++ world or the C world or the the Go world.
Well, I think one of the things you get with Java is that you get to outsource some of the problems that you typically are taking on with if you're just sort of writing something in C. It's quite a different experience to write code there, and I would actually argue that Java actually lowers the barrier of entry for people contributing these projects. Like I don't think that I've contributed patches to Java-based projects like Cassandra, but I think if it came to contributing something in C, it definitely there's like a larger barrier because you kind of don't know what you're. In a lot of ways, you don't often know what you're getting with a C project or a C++ project. But in terms of, do you understand the build tools? Do you understand like the environment? Everything's very like quite bespoke usually to the project, just because of kind of the nature of the way that those things work. And things like Java's got a lot of standards that make it fairly straightforward to contribute in a lot of ways. And I think the interesting thing here is that Java is, because it does outsource a lot of those things. I mean, something as simple as memory management, for instance. It does mean that, like, if you're running the JVM, the app developer didn't do any work for you. It's now in many ways, it's now your job to figure out what the right JVM, GC settings are, or heap settings are for your environment. And that's getting better. Like, G1 is improving that situation quite a bit in terms of having to futz with in those flags. But I think the philosophy is not
So basically,
rapidly improving in terms of.
Basically, what you're saying is that the trade-off here is Java makes things much better for developers who are immersed in that space, but much harder for operators if they are not fully immersed in that space.
Yeah, I would say that's true. I'm not sure that that's the trade-off per se. I think that's just like the choice of people who
characteristics.
not make them more human friendly. I mean, I think like if you look at there's newer generation stuff that's a little bit better. Elasticsearch is pretty straightforward as far as just installing it and like trying it out. Not so much with many of the other infrastructure projects. I think Apache projects are pretty notorious at this point for being sort of balls of Java code that are difficult to even just try out. But I think there's some change happening, but I don't know if it's going to be fast enough to supplant some of the other things that are going on in the world, like people adopting Go and Rust for systems infrastructure projects. I'm not sure if they'll be able to outrun that.
So kind of back to Brandon's point, adopting new languages, new databases, like meta point about what kind of process or what kind of thought should go into that. I'm really curious to hear if anyone else has opinions or things they'd like to bring up. Like if you have a team, do you let them use both Ruby and Python? Or do you be like, no, motherfuckers, this is the one?
Yeah, I'm on kind of a small team, and we definitely make choices. If you write in some language that nobody else can write in, you're going to get all the calls at 4 a.m., you're going to have to fix all the bugs, and we're also very big on not having single point of failures like that. So in very rare cases it happens, but you have to have some really good reason why you have to be the bottleneck for everything.
What would be some of those reasons?
Probably mostly political, unfortunately, but I work at a large enterprise, so that kind of stuff happens. I think we've had one or two things where we need something, we need it quick, we have somebody who can get it done in whatever tooling, and that's the way we roll, and we'll come back and visit it later. But I think you said something earlier about whether it's really something you want to spend that time on, or if it's just something you're going to do and then just be able to use it. Do you want to dive into that and waste time on something that isn't worth it?
There was a great presentation. It was a few years ago at QCon, and it was a gaming company. I'm trying to find it right now. I can't find it. I'll try to find the link and send it to Brandon. But it was a really cool story of how this startup, they did their first game in one framework and language, and then they decided to do a second game, and they kind of gave themselves the freedom. And in fact, I think the name of the presentation was something like, what if you could reinvent yourself? And it was, I don't know that it's, I don't know it's a model that works for everybody. But it was a fascinating presentation of the evolution of how they kind of were able to kind of segregate that process to a form of logic being each new game, and it seemed to work very well at the time. I know Zynga took that approach, and I don't think that worked very well for them. But anyway, I'll try to dig that up, and I just thought that was a very interesting what if you really did have the freedom to start with a small team if you were in a software delivery model that kind of that forced you to build new things like a gaming company. Anyway.
Chastity had an interesting point. Do you want to elaborate on that? Okay, she can't talk, so I'm going to repeat it. Chastity said that she feels like having your operational stuff written in more than one language plus shell is probably asking for trouble down the road. And I think that makes a lot of sense. And generally, whatever that language is, whether it's Python or Ruby or whatever, should probably match whatever your configuration management system is. If you're using Ansible, you should standardize on Python. If you're using Chef, you should probably just standardize on Ruby. I've been on teams where we were a little bit looser about this because we were all senior. We all had written a fairly substantial amount of both Python and Ruby. And so it was kind of like, well, all right, the Ruby AWS SDK sucks. We're going to write this component in Python because we can all read and write it, and it's fine. But that was pretty context dependent. Again, kind of looping back to the fact that there are no real rules, just like judgment calls. And I think that's really great advice. Standardize on shell plus one language that everyone is expected to be able to learn and debug, and that's like what you run your systems on. I will also, like, my shameful secret, like the thing that I always do is, like, I'm a fucking wizard at Bash, and everything else I have to think about. And so in early stages, I write so much glue that is Bash script that's just like, link this thing to this thing, push this thing to that place. And as the company gets older, like, every single piece of that Bash, every single one of those Bash scripts gets replaced, and that's good, and it's healthy. But goddamn, I can get so much done so fast, just like pushed out the door, writing quick little Bash scripts.
Yeah, we take a similar approach within my team at Travis, and that sort of the majority of Travis is written in Ruby, right? That's where it started in the Ruby community. That's where it comes from. So it's mostly written in Ruby, a lot in Rails, some in Sinatra. There was one code base to start with that it made sense to switch from a Ruby on JRuby implementation to Go because it was lightweight concurrency, things like Go routines and stuff. It made sense. And we've implemented a couple other services in Go where we felt like it did make a little more sense to, in terms of the behavior and so on, to do it in Go, but we still will often use Ruby. There's been a couple things where it's like we just wanted to do like a real simple sort of CRUD API-based thing and just, threw it on top of Rails, runs on Heroku easily. But we kind of are focused on sort of those two. It's sort of like, either sort of Ruby and Go. And I think that kind of a divide is like one something interpreted, say like Python or Ruby or PHP or like whatever, and then then you might have something else like a Go or a Rust or maybe something on the JVM. But trying to kind of keep it to two of this sort of rough divides in languages.
I think that, like, with interpreted languages too, like, honest to God, they are just easier to read and learn and debug. Right? You just add a print statement, and compiled languages, things that do more sophisticated things with, object-oriented or, they're just harder. Like, I would never be as casual about letting people use a bunch of compiled languages as I would about letting people, throw a Perl script in there into the Nagios plugins just because whatever.
And it's definitely, as we alluded to earlier, it's a different set of what you look at it in terms of, are we going to write this and maintain it versus are we going to operate it?
Totally.
When I think about operation, I think about things like, okay, what kind of logging does it have? What kind of metrics can I get out of it? Is there any body of work around like how to know when it's healthy? Is there any body of work around scaling it? How does it sort of play into like CAP, or has Jepsen been run on it? things like that. Sort of, where will it break? Are there known walls? Like, it wants all the IOPS, so give it more and more disks, or like, the default tuning is good to something, and then it'll fall over if you get over like so many rows in a table, or like, are there horror stories? Are there talks? Like, how much of that can I like absorb?
Totally, totally. And the key there is not finding the perfect software. It's getting a feel for where it's going to break. Some of the shittiest software I've ever used has done the best on Jepsen tests. It's like, okay, all that tells me is I probably don't need to worry about network partitions. It doesn't tell me anything else, and literally no software is perfect. So. Does anybody who hasn't gotten to talk want to say anything about adding new shit? There's an interesting little conversation going on. I don't know if YouTube streamers can see the group chat.
No, it's only people in the Hangout.
Yeah, people are talking about shell being glue, not applications. Couldn't agree more. Shell scripts are what you use to glue things together, and almost always they should be temporary. Like let's not wait for a week while we build this perfect application. Let's just get it going and find the rough edges and replace it.
Temporary, but stored in version control.
Yep, 100%.
Charity, was your point about interpreted versus compiled languages more about like the sort of glue stuff you're talking about in terms of operation, like what you would use to do provisioning and things, or were you talking about the actual application side of it?
I'm talking about both. I mean, like at Parse, when the API was written in Ruby, I found it way easier to just go in and just add some logging lines. I could read it more easily. I could understand it more easily. And when we rewrote it in Go, it was like suddenly like, oh fuck, like memory allocation and slices, and like this is like a different level of programming where the first time I saw a Ruby script, I understood what it was doing, right? And the first time I saw Ruby errors, I knew what they were doing. And the learning curve on something like Go or Java is way more steep because they are more sophisticated software engineering patterns, and the idiomatic things that good programmers do with them are just not readable until you learn the language.
You're talking specifically about like when you have something running in production, you're trying to understand its behavior.
Yeah.
Yeah, but isn't that contextual to how you've learned programming in general? Right? I mean, I think, the first time I saw Erlang code, not to date myself, I understood it immediately because I had done Prolog 15, 20 years ago.
There you go.
So it is, but I mean, I get your point. I mean, anybody who's done more than 2 or 3 languages, and unfortunately I don't code as much as I used to these days, but you can look at code, and I agree, things like Ruby, and, and they tend to, it's for me, even though I learned with assembler, actually, I can grok the context of what somebody's trying to do quicker through an interpreted language than I can typically compiled language.
Yeah, the more terse the language is, the more special characters it uses, the more it's just kind of like, okay, I have to go learn this language before I can debug this problem. Is all. We kind of got off on a tangent there. I was just trying to say that for languages that are more sophisticated and less outside the scope of your team's existing expertise, the more disciplined you need to be about adding more of them. So I think we're about out of time. Does anyone want to say anything super meaningful? Brandon, you want to close this?
Yeah, I had an interesting thought for a potentially future topic, and especially in thinking about bodies of knowledge around operating, stuff that's like infrastructure, whether it be an application server, a web server, a database server, a key value store, etc. It seems to me like there is a lack of like shared knowledge around operating at what I would call medium scale. I think there's tons and tons of knowledge around like I have one or two or three or four servers, or I have a small thing, and then you get the specialized, the Facebook or Google or like the hypergrowth type stories, right? Where we get a bunch of money and we hire these engineers and we do all this custom stuff. But it doesn't seem like there's a lot of like long-lived sort of medium-sized infrastructures. And wondering why that is. Maybe that's due to like acquisition.
Because they either grow or they die. Or they stay at the same place for so long that it becomes really boring and all the good engineers leave, right? So Camille tweeted something the other day, or retweeted something that I thought was really insightful, where whoever it was that said it said, everyone should get some experience at a medium-sized startup because there's kind of structure, but not really. There's kind of best practices, but not really. Like you're all in the process of figuring these things out, and I love that phase. Like that's my favorite phase because you can take some amount of what you've learned, go process at other times. You can't just like history doesn't repeat, it rhymes, right? So yeah. I feel like through my career I've gotten better at this, but I still, every fucking time I learn a lot more.
In general, that's advice I give to any young person that talks to me about doing a startup is, some people just have the Jones, that they have to do, I got to save the world and become the next Microsoft, and you can't like stay out of their way, right? Like, but in general, I tell people, take a back seat on your first startup. If you've got the startup bug, come in like 10th or 11th or 15th, but be in a position where you're part of the game. When you're within the first 20 of a startup, in general, you get a great feel for that kind of. It's not really mid-size, but you get like an incredible experience, and typically by that time it's within a year, maybe a year and a half down the road. Anyway, did we get cut off, or are we still here?
A few people still here.
No. Anyway, I think that ties into what you just said, but also I think in general, to learn how a startup works, you let the other people do the seed round funding, the how to get the organizational structure in place, when to hire, and watch that from a back seat. I think that's for most young people who want to be entrepreneurs, especially in the startup business. So that's the business
totally.
I know. And I think that lies in with the development, software, learning how to do the business stuff. And like I said, I've done 10, and every time I've sold a business, there's one thing that comes up, and I'm like, holy shit, next time I'm going to make sure I don't do that one. So like there's always a list, and I thought every time I think I got the canonical list of what to do when you're either going to start with a startup or you're going to start a startup, and there's always like, when you do some type of transaction, you're like, oh, man.
If you're in the first 20 or 30 people at a startup that achieves any sort of success, you are in a leadership role, whether you're ready for it or not.
Great, I totally agree. So, I got to probably go too.
Hey, yeah, I got to go. This is great. Thanks, yeah. Brandon.
All right. Thank you, everyone. Have a good weekend.
Oh, Rick says bye, too.
Everybody have a great week.
All right. Bye, guys.